In this video, you're going to learn how to explore logarithmic equations without a calculator. So simply by converting each of these logarithm equations from to exponential form and then solving them. I'm going to go ahead and do the left side, and I'm going to have you guys do the right side. For number 1, there's 3 parts, a, b, and c. So 9 to the exponent negative 2 is 1 over 9 squared. 9 squared is 81. 9 to the exponent 1/2. So we have 9 to the exponent 1/2. So whenever we have a rational denominator, we ask, okay, 9 is our base. What two numbers multiplied to get 9 that are the same number? That's 3 and 3. Right, so that's the 2. What two of the same numbers multiplied to get 9 is 3 and 3. And then how many of those 3's do we want? We want just one of those 3's. So we're just going to take this. So our solution would be 3. Same thing with this one. Right. We have 9, so we want how many numbers to multiply together to get 9? 2. So what two of the same numbers multiply to get 9? 3 and 3. How many of those 3's do we want? 3 of them. Well, we only have 2 of them, so we need to add one more. So 3 times 3 times 3 is 27. Number 3, we're going to convert it to exponential form. So our base here is 5, so we write it as 5 as our base. And then our exponent is 3 equals x. So 5 to the exponent 3 is 5 times 5 times 5, which is 125. Our base here is 8, so it's going to be 8. And our exponent, 5/3, equals x. What number, when multiplied by itself 3 times, gives you 8? Right. So it's something times something times something equals 8. That number is 2. 2 times 2 times 2. How many of these 2's do we take? 5 of them. We only have 3 of those, so we need to add 2 more. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this one, our x, will be equal to 32. Number 7, our base is 2. So it's going to be 2. Our exponent is x. 2 to the x equals 16. So how many times do we multiply 2 by itself to get 16? And that is 4. For number 9, our base is 5. So we have 5 to the exponent x equals 1 over 25. So 5 to what exponent is 1 over 25? And that is negative 2. How do we know it's negative 2? Well, start with the positive side of things. So let's start with 5. 5 cubed is 125. 5 squared is 25. 5 to the first is 5. 5 to the 0 is 1. 5 to the negative 1. You see the pattern is that we keep dividing by 5, right? 125 divided by 5 is 25. Divided by 5 is 5. Divided by 5 is 1. If we divide by 5 again, it's 1 over 5. If we divide by 5 again, it's 1 over 25. Number 11, our base is 121. Exponent is x. And that equals 11. So in this case, x is going to equal 1/2. We know equals 1/2 because we know that the square root of 121 is equal to 11. And we can express square roots as the exponent 1/2. Because remember, with the square root, there's an invisible 2 out here with a 1 on the inside. Right? So the square root of 121 can also be written as 121 to the exponent 1/2. For number 13, our base is 17. Our exponent is x. So if 17 to the exponent x is equal to 1. So in this case, x is equal to 0 because anything to the exponent 0 is 1. Number 15, our base is x. Our exponent is 3. And that's going to equal 64. We want just x by itself, so we're going to multiply this 3 by the reciprocal of 3, which is 1/3. And when you do that, these 3's will cancel out, and you're left with just x to the first, or just x. And 64 to the exponent 1/3 is 4. And we know that because we need 3 numbers, 3 of the same numbers that multiply 3, the same numbers that multiply to get 64, which is 4. 4 times 4 times 4. And when we want just one of those numbers, so it's just going to be 4. For number 17, our base is x. So we have x to the exponent 1/2 is going to be equal to 4. Again, the same way you solve it as number 15. You multiply by the reciprocal of 1/2, 2 over 1. And 4 squared is 16. So x will be equal to 16. Let's circle our answers here. For number 19, our base is x. Exponent is negative 2. So it'll be x to the exponent negative 2 equals 4. You're going to do it the same way. Multiply by the reciprocal of negative 2, which is 1 over negative 2. Oops. Times 1 over negative 2. Exponent 1 over negative 2. So we're going to have our x equal to 4 to the exponent 1 over negative 2, which is the same thing as 1 over 4 to the 1/2, which is the same thing as 1 over 2. So x will be equal to 1/2. And for number 21, our base is 4. Our exponent is going to be x. So it's going to be 4 to the exponent x equals 2. So again, x is going to be equal to 1/2. Now go ahead and try the evens of this worksheet.